5 years. I'm discussing this again. The annuity pay 8% interest rate compounded annually. So you see for the first questions, the 1,000 is deposit every year for 5 years. That's why the period here is in year. Okay, so I make it 1 until 5 because for 5 years. Beginning amount, the first period, always 0. Why? Because from the case scenario, we can see that 1,000 is invested at the end of the year. So beginning of the first year is still 0. From there, 0 amount, 0 interest is earned, and at the end of the first year, 1,000 is deposited into the account, and that gives the balance as 1,000. Balance of the first period will become the beginning amount of the second period, 1,000 here. So how do we get the interest here? You have to show the working start actually. The formula to get the interest, I equals to T multiplied with R over M. So this one, I equals to, for the second period there, 1,000 multiplied with R, 0.08 over 1. Why 1? Because compounded annually. We don't have to adjust the annual interest. The period is in the year already. Okay, show all how you get the interest value for each of these, and you can see the answers are here. Check your value, and at the end of the second year, another 1,000 is deposited into the account, and to get the ending balance, you always plus beginning amount, interest earned, and the deposit made. Then that's how you get the ending balance. The process will repeat until the last period. First, the A, this scenario A is quite simple because it's in year. Look at the orange color here. 300 is invested in an increasing annuity at the end of each year for 1 year. The annuity pays 6.5% interest rate compounded quarterly. Now, compounded quarterly give us M equals to what, guys? Compounded quarterly M equals to? Can any of you answer? 4, correct, you know. M equals to 4. So since the deposit is made every quarter, you will see here period is per quarter and the period of investment is 1 year. So in 1 year, there are 4 quarters. That's why you see here first period, second, third, and fourth quarter. Okay. And how do we get the interest here? So look at the second period here. How do we get 488 cents here? It's still using the formula I equals to P times R over M, where P is 300 multiplied with R. R for this case is given as 6.5%, 0.065 over M, divided by 4 now. So every time you multiply with the principal, multiply with R over 4. Okay, R over M. All right. In the third case scenario, 80 ringgit is invested in an increasing annuity at the end of each month for 1 year, 3 months. So the period will be in month now because the trend of deposit is every month. And from the period here, how many period do we have? How many row we will have? 1 year, 3 months, we will have 15 months. That's why here you see the first period until the 15th period. And to get the value of M here is decided by this compounded monthly, give us M equals to 12. So every time you want to find the interest, it is I equals to principal multiplied with R over M. Let's say we look at the second period here. Okay, for second month, beginning amount in the account is 80. So that will be the P value. Multiply with R, 2.3%, 0.023 over M, 12. That's how you get 15 cents. Okay, the process repeat until the 15 months. Question number D. Okay, scenario number D. 500. Oh, sorry. Hold on, yeah. Why make it in month here? Okay. 500 is invested twice a year. So this is every 6 months. Okay, not month. Every 6 months, twice a year. Deposit is made every semi-annual for 5 years. So in 1 year, there are 2 semi-annual. So 2 times 5, there are 10 periods. Right? And compounded semi-annually give us M equals to 2. 6% is the annual rate, the R. Okay. For the first period, the beginning amount is always 0 with the 0 interest earned. Second period onward, there will be interest earned. How you calculate the interest? Again, it will be I equals to P multiplied with R over M. You take the beginning amount of every month and then you multiply with R over M. For example, second month, 500 multiplied with 6%, 0.06 over M over 2. That's how you get 15 ringgit as the interest. Okay, so when you have to create the table of account, you have to actually go through period by period. Any of you have questions regarding the account here? Anyone? Not clear? No? Alright, if no, let us move on to the questions involved with the formula. Question number 2 onward. You don't have to create the account, but you can use the formula. The question number 2, two parents decide to deposit 40 ringgit a month. You see here, the trend of deposit is several deposit made, 40 ringgit a month. Okay, not one time, but every month they will deposit 50 ringgit into the saving account of their child. The account earns 6% interest compounded monthly. Compound time always follow the deposit trend. What is the balance after 15 years and after 18 years? To find the balance means you have to find the accrued amount, the A. And the formula will be the one that you learned last Monday. A equals to, let me just copy from the slide and put it here. A equals to P multiplied with PMT multiplied with the whole bracket there, where PMT is the amount of regular deposit made. So let us take out the information. PMT equals to 40 ringgit. Interest rate 6%, 0.06. M, compounded monthly M equals to 12. And T, there are two questions here. The first one, 15 years. Okay, for T equals to 15, then the balance after 15 years will be PMT 40 multiplied with 1 plus R 0.06 over M 12 to the power of MT 40 times, 12 times 15 is it 180? 12 times 15. Yes, 118 minus 1 divided by R over M, 0.06 over 12. Okay, so here the A will be equals to 11,632 ringgit 75 cents. And for T equals to 18, you just need to change this. Okay, now M times T, 12 times 18 will be 216. You still use the same formula, which is to find the accrued amount. You can try that yourself. The answers are there. Question number 3. If you have questions, you can put in the chat room or turn on your mic. If no questions, then I'll just continue. Question number 3. A newly married couple are both working and decide to save 1,000 a month for a down payment on a home. The account earns 8.5% compounded monthly. How large a down payment will they save in 3 years or in 4 years? So again, there are two questions here with different T. The first one is T equals to 3. The second one is T equals to 4. And the questions ask how much they can save in 3 years or 4 years, means to find the balance of account. To find the balance is to find the accrued amount. So the formula will be A equals to PMT multiplied with the whole bracket there. Okay. And now 1,000 will be the PMT, 8.5% will be the R, compounded monthly give us M equals to 12. So for T equals to 3, just put it in the formula, 1,000 multiplied with 1 plus R, 0.085 over M, compounded monthly M equals to 12 to the power of MT. 12 times 4, 48 minus 1 divided by R over M, 0.085 over 12. Sorry, 12 times 3 is 36, right? Not 4. Now we do for T equals to 3. So this one, 12 times 3, 36. Then you can get the final answer. When T equals to 4, then the M times T will be 48. Okay, still use the same formula, you just change the T value. So question number 2 and number 3 are similar. Same goes to the question number 4 and 5. Question number 4. Adrian has decided to save 500 a month for 2 years. How much will be the balance in the account if the account pay 2.5% interest rate per annum compounded monthly. You want to find the balance. And you see here, even though it didn't state that this is annuity, you have to see the pattern of the opposite. Adrian save 500 a month. Means Adrian will put in the value in the account 500 every month. Several equal deposit is made, which is increasing annuity account. So the formula is still the same formula to be used. This formula on the screen that you see now. Okay, where 500 is the PMT. T, period of investment, 2 years. R, 6.5%, 0.025. Compounded monthly, M equals to 12. So A equals to 500 multiplied with 1 plus R, 0.025 over M to the power of MT, 24 minus 1 divided by R over M, 0.025 over 12. Then that's how you get the answer, 12,291.94 cents. M equals to 1. Compounded monthly. If compounded monthly means in 1 year there are 12 months, so M equals to 12. It becomes 1 if compounded annually. Per annum? No. The R given is always per annum, 2.5% per annum. 2.5% per annum. But the interest is compound every month. That's why you have to convert the yearly rate to monthly rate. Okay, number 5, similar to the numbers 4 just now. Sarah has decided to save 100 for every 2 months in the annuity account that pay 4.2% interest rate per annum. It owes per annum, but compounded every 2 months. How much total savings she has made after 5 years? So after 5 years, the total saving means to find the A. The formula, oops, is which is now PMT is 100. In 5 years, T equals to 5. R, interest rate per annum, 4.2%, 0.042. M, compounded every 2 months. So in 1 year, there are 6 of every 2 months, right? 6 times 2, 12. So M equals to 6 now. To find the total saving means to find the accrued amount equals to PMT 100 multiplied with 1 plus R 0.042 over M 6 to the power of MT 6 times 5 30 minus 1 divided by R over M. R over M are 0.042 over 6. And you will get the answer. Alright, that is the question number 5. Okay, question number 6, 7, and 8 are similar. Let me just check how many questions we have. Oh, 13. Okay. Okay, question number 6. How much must be deposited each month into an annuity, paying 7.5% in compounded monthly to attain the balance of 25,000 after 5 years? So these questions, what actually you have to find? Is it still to find the balance in the account? Correct, Nishan. Okay, so you have to find the value of PMT. Question number 6, 7, and 8, you have to find the value of PMT. How much should the saving make? How much should they deposit? All that is to find the PMT value. So to find the PMT value, you still use the same formula. It comes from the same formula, but you have to adjust the formula. My advice is before you put in all the value in the formula, adjust first. Okay? So write first in the PMT value, PMT form, PMT equals to A divided by 1 plus R over M to the power of MT minus 1 over R over M. So A, 25,000 divided by 1 plus R 0.075 over M compounded monthly, M equals to 12 to the power of MT. 5-year T equals to 5. 5 times 12, 60 minus 1 over R over M. 0.075 over 12. And that's how you get the answer as 344 ringgit 70 cents. Question number 7. How much must be deposited every other week? Every other week means every 2 weeks. Okay, this week deposit, next week we don't deposit, and then another week we deposit. So that's what it means by every other week. Every 2 weeks. To attain the balance of 800,000, 8,000, not 800, 8,000 after 3 years. So we still want to find the PMT, then you have to adjust the formula. Alright, PMT divided by the whole A over the whole thing here. PMT equals to A divided by the whole bracket. Alright, but now let us take out the information. 6.5% interest. So R equals to 0.065 compounded bi-weekly. Okay, what's the value of M here? Compounded bi-weekly, M equals to 26. Very good, Nishan. Okay. In 1 year, there are 52 weeks. And if you want every 2 weeks, then 52 divided by 2 is 26. Balance, which is A, 8,000. T, 3 years. So PMT equals to A, 8,000 divided by 1 plus R 0.065 over M, 26 to the power of MT. 26 times 3 is 78, right? 78 minus 1 over R over M, 0.065 over 26. Oops, 26. Okay, then you can get the answer. Question number 8. Melissa planned to buy a laptop. The price of the laptop is 3,500 ringgit. How much will she need to save every month in an account that offers 5% interest rate compounded monthly in order to buy the laptop in 1.5 years? Laptop price will be the balance, the end of the saving. So laptop price is the A, 3,500. R, 5%. Compounded monthly, M equals to 12. And the investment or the saving is made in 1.5 years, means 1 year, 6 months, or 1.5 years. So to find the amount of saving needed in every month, for every month, means to find the PMT value. PMT equals to A, 3,500 divided by 1 plus 1 plus R over M, 0.05 over 12 to the power of mt, 12 times 1.5, 18 minus 1 divided by R over M, 0.05 over 12. Then you can get the answer 187.65. Okay, that's how you adjust the formula to find the PMT, which is to find the amount of deposit needed to get certain balance. Okay, the questions for the increasing annuities, any of you have any issue or questions to ask before I continue with the decreasing annuity questions? No? All right. If no, then let us move on to the questions for decreasing annuities. The first one, number 9, find the present value or initial deposit needed, the total amount withdrawn, and the total interest for the following decreasing annuity. I will just discuss one out of 3 here. Maybe I discuss question number 3, the C here. Okay, so A and B, you try yourself for your practice. I will discuss this. The account pays 10% compounded quarterly. Withdrawal of 5,000 per quarter are made for 20 years. So we want to find present value. First question, present value. To find present value, you need to use the formula. Okay, and the formula for the present value is this. Okay, present value P equals to W multiplied with the whole bracket there. So let us take out the information. 10% interest, R equals to 10%, 0.10. Compounded quarterly, M equals to 4. Withdrawals of 5,000, withdrawal is W. 20 years of withdrawal period, T equals to 20. So we have all the information needed. Now let us find the present value. Put all the value here in the formula. 5,000 multiply with the whole bracket here. 1 minus 1 over 1 plus R. 0.10 over 4 over M. Okay, to the power of MT, 4 times 20 is 80 over R over M. 0.10 over 4. So by using this formula, you will have the present value as principal amount as 172,259 ringgit 9 cents. Okay, to find the present value, always need to use the formula. Okay, next what you need to find, total amount withdrawn. Okay. Withdrawal amount is 5,000. 5,000 is withdrawn every quarter for 20 years. Okay, so this is first to find present value. Second, total amount withdrawn. Total withdrawal. Okay, you take W, which is for this case 5,000, multiply with, in 20 years, there are how many quarters we have? 20 times? How many quarters we have in 20 years? Yes, 4, right? In 1 year, we have 4 quarters. In 20 years, we will have 80 quarters. Means there are 80 times of deposit made. So 5,000 times 80. 400,000. Okay, I will put in the symbol here. Comma 400,000. Okay. Okay, that is the total withdrawal. Next, total interest earned. So how to get total interest earned? It will be total withdrawal, the answer for the question number 2, minus the answer for the question number 1. Total withdrawal minus present value. Yes, correct. Okay, correct, Mission. Very good. Right, so that means 400,000 minus present value 1,000, 170,000, 72,259 ringgit 9 cents. Here, let me just take the value here. This is the answer. 227,740 ringgit 91 cents. Alright. So to find present value, always use the formula. To find total withdrawal, you have to make sure you know how many times of deposit is made. And to find the total interest earned, always make it total withdrawal minus present value. Okay? Okay, that is question number 9. Okay, question number 10. Find the amount of each periodic withdrawal for the following decreasing annuity, means to find the W. To find the W, you have to use the same formula, which is this formula, but you have to adjust the formula. It will be equals to, from this formula, it will be equals to W, W equals to present value divided by 1 minus 1 over 1 plus R over M to the power of MT over R over M. Okay, so from the case scenario here, annual withdrawal from a 50,000, so P is 50,000, paying 8%, the R is 0.08, compounded yearly, yearly means annually, M equals to 1. For the period of 5 years, 10 years, and 20 years, there are 3 questions here. So T equals to 5, T equals to 10, T equals to 20. So you just put in all the value inside and find the withdrawal amount for each of the T value here. The answers are given. So please make it as your practice. Same goes to the question B, monthly withdrawal. And compounded monthly gives us M equals to 12. 9.5%, 9.5% means 9.5%, which is 0.095 as the R. 100,000 here will be the present value P. And you have to find when T equals to 2 years, 5 years, and 10 years. So again, use the same formula, which is the formula to get the W, but you have to actually change the value of T every time here to get number 1, number 2, and number 3. Okay, number 12, number 11 and 12 here is about the account of withdrawal, account of decreasing annuity. Question number 11, a person deposit 3,660 ringgit 4 cents in a decreasing annuity on June 1st, 1990. After a year, in June 1st, 1991, the person will withdraw 2,000 a year for 2 years. The account pays 7% compounded annually. Compute the following decreasing annuities. Complete this decreasing annuity account. So on 1990, nothing happened yet because they only put in the amount here. Again, then withdrawal. Okay, after 1 year, withdrawal of 2,000 is made. Okay, withdrawal of 2,000 is made. Then here, since after 1 year, there will be an amount of 3,660 ringgit 4 cents in the account. So this amount earn interest. Okay, the interest is 7% compounded annually. And as you see here, the period is in year. So to find the interest, it will just be I equals to P times R, because R over M equals to 1. So here, 3616.04 multiply with 0.07 over 1. That is how you get the interest value. So once you get the interest value here, to get the balance before withdrawal, they say this is A and this is B. So balance before withdrawal will be A plus B. Okay, so what they say equals to C here. So once you get the balance before withdrawal, you minus the withdrawal amount, then that's how you get the balance after withdrawal. Alright, hold on, yeah. Is it? No. 3616.04 times 0.07. Oh, sorry. 3616.04 times 0.07. Yep. Same as I got the same answer, same value. Okay, once you do this, it will be here equals to 253.12. Okay, let me just put the value here. And before the withdrawal, you just plus them together. 3616.04 plus 253.12. Then you will have here 3869.16. And then withdrawal of 2000 is made. Withdrawal of 2000 is made means you minus. Don't plus, but minus. So when you minus 2000 from the amount, it will be equals to 1,869 ringgit 16 cents. Same as yours. So this balance will be the new amount in the account for the for 1992 after another 1 year. And to get the interest value, you just multiply with 0.07 because it's compounded annually, so simpler. And for 1992, the interest is 270.84. And before the withdrawal is made, in the account you will have 3869.16 plus 270.84. Ngam-ngam. Not ngam-ngam. 841. Oops. What happening here? We should get ngam-ngam, right? Oh, sorry. Why is it still 3? 1, right? Okay, 1,8. I don't know why I make it 3 there. So it's not his value. Hold on, let me calculate again. 1869.16 multiply with 0.07 is actually 130.84. Then you plus with the principal of the 1992 is about 2,000. Okay. If you round off to the 2 decimal, so you got 2,000, right? Ngam-ngam. Then you minus the final withdrawal until the account is depleted. Correct, Nishan. Don't know why. Okay? Yeah, you will see in the decreasing annuity, the balance is always zero. The account is always depleted. Okay, you can try this by yourself. Okay, I think I will put the value here because I want to put the answers of this.